So let's think about these different systems of equations. And let's think about how we can discover how many solutions they have. Well, if you remember back to chapter 3, we can test to see if two lines are parallel by checking their slopes. But when we're checking their slopes, we had this additional requirement. I said that not only do their slopes have to be the same, but the y-intercepts have to be different, because we wanted to avoid, this possibility right here, the two lines being overlapping. But it turns out if that's our other scenario right here. So those are kind of, that's exactly what we're going to check for here. We're going to say if they have the same slope. Well, actually, let's start off with this one over here. If they have a different slope from each other, then we're in this scenario. Because if they have a different slope, that means they have to intersect in exactly one point. If they have the same slope, but a different y-intercept, if they have the same slope but a different y-intercept, then we're dealing with parallel lines, and that means we're in this situation where we have no solutions. And if they have the same slope and the same y-intercept, that means we have, well, the same line, and so we're in this scenario over here. So that really means that for each of these 6 different equations, I need to just put them into slope-intercept form, and then I can decide which scenario I'm in. So this is a little bit of a practice in putting stuff into slope-intercept form. So this first equation, starting with x minus 3y equals 4, I'll start by subtracting x from both sides, giving me negative 3y equals the opposite of x plus 4. You can see I subtracted x from there and picked up the opposite of x over here. Next, I want to get rid of this negative 3, so I'm going to divide both sides by negative 3, giving me y equals, taking a negative divided by negative, and that 3 is in the denominator, so this is going to be positive 1/3 x minus 4/3. So this first equation, when in slope-intercept form, is y equals 1/3 x minus 4/3. The second equation, 2x plus 7y equals 7. Well, let's see, subtract 2x from both sides, I get 7y equals negative 2x plus 7. Divide both sides by 7. I get y equals negative 2/7 x plus 1. You can see the slope of the first line is 1/3. The slope of the second line is negative 2/7. They have different slopes, which means we have the scenario where we have exactly one solution. All right, more of the same for this one. Again, putting it into slope-intercept form, 6x plus 4y equals 4. I get 4y equals negative 6x plus 4 when I subtract the 6x from both sides. Then divide both sides by 4, giving me y equals negative 3/2. I'm also reducing my fraction, plus 1. The 6 divided by the 4, well, there's a common factor of 2. When I cancel, I get the 3 and the 2 there. And you can see the negative is still out in front. So I get negative 3/2 x plus 1. That's my first equation. For my second equation, I have negative 12x minus 8 equals negative 8. Looks like I want to add 12x to both sides. I get negative 8y equals 12x minus 8. Divide both sides by negative 8. I get y equals, let's see, this is a negative, because I'm taking a positive number divided by negative. There's a common factor of 4 that I can cancel, leaving a 3 up top and a 2 down below. Negative 8 divided by negative 8 is positive 1. And hey, look at that. It looks like both of these equations are exactly the same. We have the same slope and the same y-intercept. Negative 3/2 for the slope and a 1 for the y-intercept, which means we're talking about the same line, so we have infinitely many solutions. And process of elimination, you can probably guess what this last scenario is going to be, but don't make that assumption. It might not be. Let's actually try it. So for the first equation, we have 3x minus 4y equals 8. Putting this into slope-intercept form, I have negative 4y equals negative 3x plus 8. Divide both sides by negative 4. I have y equals 3/4 x minus 2. Negative divided by negative is a positive, and I get 3/4. There's nothing to cancel there. And over here, I'm taking a positive divided by negative, which is why I have a negative 2. 8 divided by 4 is 2. All right, so that's my first equation. For my second equation, I have negative 6x plus 8y equals 8. Let's see, add 6x to both sides. I get 8y equals 6x plus 8. Divide both sides by 8. I get y equals, I can reduce this fraction. There's a common factor of 2. So when I do that, I get 3/4 times x plus 1. So these two equations, they have the same slope, but a different y-intercept, which means we're in a situation where the two lines are parallel. So this would be a situation where there are no solutions.